Hello class, this video I'm gonna show you how to solve lab 5, which is for week 6. So I'm gonna go over all the questions in lab 5, and this week 6 is due by Sunday, June 12th. So make sure you submit everything on time, okay? And also when you're done, make sure you do your quiz 5. Okay, so now starting with this video, I have lab 5 has two parts. One of those is talking about a system of equations, and the second part is about conic sections. So I'm gonna go over the first 5 questions about system of linear equations. So what is system of linear equation? So looking at all the examples, they have two linear equations which make a system. So the graph of linear equation is a straight line. So if you have two straight lines, all possible cases, and these are the notes from the handout I pass in class. So the possible cases for two straight lines, if they are parallel. So this is the first case when you have two parallel lines. The second case is if you have two lines which cross each other in one point, point P. And the third case is when the two equations represent the same straight line, which means just think about like two lines in top of each other. Okay, so what are the solutions for these three different cases, and what is the name of the system? So system have a different name, the same way like linear equation was identity, conditional, and contradiction. The same way the system of equation have specific name. So the first case, when you have two parallel lines, there is no solution. The system have no solution because the two lines never gonna cross each other. So that's the solution, no solution. And the system is called inconsistent. The second case, when you have two lines which cross in one point, the point where they cross is the solution. So the solution looks like coordinates of points. The first number is x, the second number is always y. So always when you solve a system, make sure you have two numbers, one number for x and one number for y. And the name of the system is independent. So when you have one solution, the system is called independent system. And then the third case is when you have two the same lines. The solution is called general solution, or technically when you plug it in the calculator is going to say infinite solutions. And that means any point from the line is a solution. So technically you have infinite numbers of solutions, infinite points, which means all the points in that straight line, they are solutions. And the system is called dependent. Okay, so these are the three different cases, and we're going to start with, going back to your lab, we're going to start with number 1. So number 1, it says fill the blanks. The equation of the system are dependent or independent, which means is the system have infinite solutions or just one solution, one point. How you do that? How you solve a system of equation? So I'm going to show you how to do that on your calculator. So get your calculator, and I'm going to show you how to do it on your calculator. So on your calculator, you're going to press second first, and then you're going to press tangent. This is like function which gonna solve system of equations. So press second tan and then press enter, and you're gonna see in the screen, you're gonna see something like this: x and y equals something. You're gonna see the system, like a system of equation in standard form. So what you need to do is you need to enter the numbers in front of x and y. So for example, the equation where, let's say we're solving 1x plus 1y equals 5, for example, and let's say the second one is 2x plus 5y equals 7, for example. So if I want to enter this equation, I'm going to start with adding up the numbers, and you're going to write the number here. And then when you press enter, so press enter, it's going to take it wherever the marker was. And with the circle, you can just go left to right and put all those different 6 numbers, okay? So put the number here, press enter, it's going to put it in the place where you need to put that number. And after you finish all the numbers here, these 6 numbers, down here is gonna say solve. When you click on solve and then press enter, you're gonna solve the system, okay? And when you press solve, you're gonna get in the screen again. So everything I'm writing here is on your screen. On the screen, after you click at solve and press enter, on the screen, you're gonna get x equals number and y equals number. So those are gonna be your solutions, whatever x and y is. Now, if the system have no solution, it's gonna just have a white, green screen is gonna say no solutions, or if the solution have, if it's dependent or have infinite solutions, it's gonna say infinite solutions, okay? So that's how you solve a system of equations on your calculator. You can solve any system of equations. The only thing you need to be careful is you have to have the system in standard form, which means x and y in the same side equals number, both of the equations like that. So that's what you're doing. You press, first you're going to press second, then you're going to press down, and then you're going to press enter, and then enter the system and solve. So that's simple, okay? Unfortunately, I can't show you how to do it, but I just show you what to press and do it, okay? So that's how you solve a system of equations. So let's go back to the lab and let's start doing that. So the first one, if you enter this system of equation number one, what you need to enter is 1 in front of x, 1 in front of y equals 8, and then 1 in front of x, negative 1 in front of y equals 1. And when you press enter and solve it, it's going to give you solution. It's going to give you x equals something, y equals something, and that means you have different numbers, so I don't want to give you exactly what it is, but mine is independent because I have x equals number and y equals number. Okay, so you solve your system, depends what you got, and then you're gonna, if it says infinite solutions, then it's gonna be dependent. Okay, number two, going to number two. Number two, we have to check if the pair 9 and 4 is a solution or is not a solution of this system. Okay, so here you can just plug this system and see what is the solution, but here it's a trick because if the system has infinite solutions, any point on the line is going to be solution. So technically, the better way to do this is if you plug x is 9 and y is 4, so plug those two numbers in both equations, and if they're true, is a solution. If one of those equations is false, then it's going to be no solution. So it's not a solution. So let's check it. And this is how you can check your answer. So I'm going to take the first equation first. So I'm going to replace x with 9 because that's what they give me here. X is 9 and y is 7. I'm sorry, 4. Y is 4. So I have 3 times 9 plus 4 equals 31. I'm plugging it into the first equation. And then let's see if that's right. So I have, what is 9 times 3? 3 times 9 is 27, plus 4 is exactly 31. That's right. And then plug it in the other one. So I have 9 is my x, minus 3 times 4 is y, equals negative 3. Is that right? So we have 9 minus 3 times 4 is 12. 9 minus 12 is exactly negative 3, right? So this is true statement. So that means these two numbers, this pair or this point, is a solution of the system. And I'm going to submit all of my answers so you see that I'm doing it correct, okay? So that was number 2. Then going to number 3 is the same way. So number 3, number 4, and number 5, you're going to plug it in. But number 3, what you need to do is just move the first equation. You have to change it a little bit because it's not in standard form. It's in slope-intercept. So what you need to do, you need to subtract 2x in both sides to move it over, and it's going to be in standard form. So I'm going to do minus 2x in both sides. So I'm going to get negative 2x plus y equals negative 12. This is my first equation. And the second is x plus y equals 15. And that's what I need to plug in my calculator to solve it. So I'm going to do that in my calculator real quick. And 1x, I'm sorry, -2. Okay, see that fast? I got it. So x is 9 and y is 6. So that's what I get. X in the calculator, I see in my screen, x is 9 and y is 6. And what you need to plug it in here, it have to be exactly in that order. X is first, so it's going to be 9, comma, 6. You don't put x equals, y equals, you don't put parentheses, you already have parentheses. You just put the two numbers in the answer box, okay? So be careful with that. And that was correct, okay? The calculator did it right. So now the next one the same way, just plug the numbers and the calculator is going to solve it, so I'm not going to do this. And let's do the last one, the number 5 is the last system of equation. So what you need to do here, first you have to simplify your equations by hand technically. So you have to do the parentheses here, you have to make the two equations in standard form. Okay, so what I did, I just screenshot this question and I put it in a Word file. Okay, there you go. And I'm gonna write here because it's easier for me to write on a Word file because, I mean, long story short, when I use like annotating the sharing screen, sometimes it disappears. So anyway, so let's do that. So first I'm gonna do the parentheses, right? And I'm going to do these parentheses also later. So first I'm going to start with the first equation. So I have 3x equals 4 times 6 is 24 minus 4y. So what I need to do is move x and y in the same side. So I'm going to add 4y in both sides. And I'm going to get 3x, make sure you put x in the first place, plus 4y equals 24. So this is my first equation. So I'm rewriting the first equation is 3x plus 4y equals 24. So that's my first equation. Then I'm going to do the same with the second equation. I'm going to do the parentheses and move everything x and y in the same side. So when I do the parentheses, 3x and 3 times -9, I'm going to write it here. It's going to be 3x minus 3 times 9 is 27. Plus 4y equals 0. Now x and y are going to stay in this side. I need to move 27. The number needs to go in the other side. And then this cancel and we have 3x plus 4y equals 27. So this is my second equation. So the second equation is 3x plus 4y equals 27. So this is my system. So now I'm going to enter that system when I go to my calculator, press second time, and then enter. And then I'm going to enter 3 in front of the first x, 4 in front of the second, the first y equals 24. And then do the same, 3 in front of x, 4 in front of y equals 27. And then when you press enter, you're going to see no solution. I mean, that's what I see. If you, I recommend you work my problems and then you do yours. So that way you're going to learn how to do it. So the calculator said no solution. Okay, that's what the calculator says. So going back to my system, I'm doing number 5. It says if the system is inconsistent, enter inconsistent. So remember, if you have no solution, what kind of system is it? It's inconsistent. Now the system is dependent if you have general solution. General solution means when when you solve it and the calculator says infinite solutions. Okay, so here I'm gonna put inconsistent. Make sure you spell it correct. It doesn't have to be capitalized. Just make sure you spell inconsistent correct. And that's my answer for number 5. Okay, that was correct. So this concludes pretty much solving a system of linear equation. Make sure you work with both of the equations, make them in standard form, and then calculate. Okay, the second part is about conic sections. So I'm gonna just show you a little video here about conic sections, just to explain, to see what is conic sections. And then you're gonna talk about equation of conic sections. So let's just watch this for a second.
Take this three-dimensional right circular double-napped cone. We can create different two-dimensional figures by taking a plane and swiping through the cone in different ways. If the plane goes from one side of the cone to the other and is parallel to the base, we get a circle. If the plane does the same thing but is not parallel to the base, we get an ellipse. If the plane cuts from the side of the cone down through the base, we get a parabola. And if the plane cuts all the way from one base to the other, we get a hyperbola. So these are called conic sections because they are literally different cross sections of a cone. We can also
Okay, so this is important. So we have these 4 different shapes, which are called circle, ellipse, parabola, and hyperbola. All these have something in common, that they are conic sections, and also the equations of all of those 4 different shapes, the equations of all these 4 shapes, circle, ellipse, parabola, and hyperbola, the equations are quadratic. They have quadratic x and quadratic y, which means in the equations you have x squared and y squared. So that's what they have in common. So now, going back to my week 6 material, we're gonna use the formula sheet we have. And these are all the conic sections and all the formulas are here. So let me explain. So we have equation of circle. So this is the equation of circle. We have equation of ellipse. And down here we have equation of hyperbola. So everybody have this in the formula sheet. And we're going to talk about all of these different equations. Parabola, we already talked about parabola in week, I think week 3 we talk about parabola. And if you remember the graph, we found the vertex of parabola. If it's up and up, up and down, and all that. And the equation of parabola was y equals x squared. So again, you have x squared in that equation. So now, talking about circle. So this is the equation of circle. X squared plus y squared equals r squared. R is the radius, and the center of the circle is at 0, 0. Now, I assume everybody know what is a circle, right? So, but I'm going to draw a picture here. So this is the circle. You have your x-axis, you have your y-axis. The center is the point. Now, sometimes could be 0, 0, and we're going to talk about only the case when you have 0, 0. And the radius is the distance from the center to any point on the graph, any point on the circle. So all these lines from here to here and everywhere, they're the same length. So that's called the radius. Okay, that's the letter R. R is the radius and center 0, 0. So, talking about circle, circle is very easy and simple. Going back to my handout here, we have given equation for number 6. We continue with number 6 in the lab. Number 6, we have to find what is the center and what is the radius if the equation is given in this form. So equation, it doesn't look exactly x squared plus y squared equals r squared because there are 2 forms of the equation. One of them is standard form, one of them is general form. So standard form, if you remember standard form from linear equation, x and y are together and everything else in the other side. So, and this is general form. The way they give me this is called general form equals 0. So what you need to do is just add 64 in both sides. and you're going to get x squared plus y squared equals 64. So this is the equation of the circle. And the circle has center 0, 0. So I'm going to put 0, 0 is the center because if it's x squared plus y squared, that's the center always. And the radius is, see the formula is x squared. I'm going to write the formula again here. Plus, you can look at your formula sheet also, x squared plus y squared equals r squared. So comparing with the formula and the equation we have here, see r squared is 64, right? So what is r? Can you find r? If I have r squared equals 64, because those two are the same, right? So which number square is going to be 64? So what times what is 64? Obviously r is going to be 8. Because to solve r squared equals 64, I need to take square root of 64. Square root of 64 is 8. So that's my radius 8. So that's how you do this question, nothing else. So I'm just going to plug it in 0, 0, 0, comma 0. That's how you enter it. You have parentheses around. You don't do anything. And 8 is my radius. Okay, that's the answer for number 6. Just take square root of the number, and that's your radius. And the center is always 0, 0 for the equations we're going to solve. Now, number 7, it's another one where they give me the graph of the circle, but I need to find the equation now. So how are you going to find the equation? Again, you're going to start with the given equation. What is the equation? X squared plus y squared equals r squared. This is where you start. Now, we have center 0, 0, right? Obviously, that means this is the equation I'm going to use. Now, we have given only a point. My point given is negative 3 and 2, so I'm going to replace x with negative 3 and y with 2, because always the point has coordinates x and y. So when I put x and y in this equation, I'm going to find what is the radius. And that's how I'm going to get the equation. So plug it in. We have, make sure you put parentheses around the negative 3, especially negative 3 square plus, put parentheses again, 2 square. And that's going to be the radius square. And when you put this in the calculator, or just simplify it, 9 plus 4 is 13. So the radius square is 13. So the answer in standard form is going to be x squared plus y squared equals 13. Now here you notice that I don't square 13 because it's already r squared is 13. Okay? So 13 is my radius squared already. So that's what I need to plug it in here. So I'm gonna just, this is how you enter it. When you click inside the answer box, I'm gonna put X, and then I'm gonna make it small so you can see the math path. For square, you click on that in the end, square. Make sure you get down of the square, and then you put plus y square again. Make sure you get down, equals 13. So that's my standard form. Now, how you get the general form? It's going to be pretty much the same equation, just 13 has to be in the other side and to be equal 0. So it's going to be x squared, and I need, oops, I press it 2 times, hold on. I need to get down of the square, and then I have to enter plus y. I need to click at that to make a square, and then I have to do minus 13 equals 0. Because when I move the 13 over, I have to subtract 13 to be equal 0. So the general form always have to be equal 0, and the standard form x and y in the same side equals number. So that's how you remember those. And let's check the answer. Okay, so that's how you do circle. Now the next questions we have here, they're about ellipse and hyperbole. So we have like 3 questions, ellipse, or 4. So you just have to read it. Ellipse, it's gonna say ellipse, and see the bottom one says hyperbola. So read it, you need to read it. Okay, so starting with number 8. So number 8, we're talking about ellipse, center of the origin, and major axis and minor axis. So let me explain what that means. So ellipse, let's talk about ellipse. I'm gonna make it bigger. And we're going to talk about ellipse now. So this is the ellipse. This is the graph of ellipse. So what you have in ellipse? Ellipse have a center. This is where the center is. Looking at your graph, this is the center. Also, the ellipse have major axis. So this is the major axis, which is bigger for ellipse, and minor axis is perpendicular. So the points, end points here, they're called vertices. So there are two vertices. And also you have 2 points which are called focuses. So those 2 points are called focus 1 and focus 2. So those are 2 focuses. You have 2 points which are focus. Now the focuses they're using to graph the ellipse. Okay? So those are very important points on the ellipse. So now what you have, these are the things you need to remember. So the distance from center to focus is called C. So that's the letter C. And this is the same over here. B is half of the minor axis. So this was the minor axis. So this is B. And this is also B. Sometimes they're going to give you the minor axis. So when you divide it by 2, it's going to give you B. And A is center to vertex, or also half of the major axis. So A is from vertex to center. That's A. So, and the same way in this side. So remember, you always have 2 focuses, 2 vertices, and all of those 3 points, vertex, focus, and center, they're located on the major axis. Okay? And you have also minor axis. So those are the things important and given for ellipse to find the equation. Now, why need all this ABC? Because if you look closely to the equations, you have A and B on the formulas. And if you remember, I told you all the equations of line, circle, parabola, hyperbola, anything, all the equations, they have x and y and other letters like h and k and a and b in this case. And all these letters, they represent something, they're numbers. So in your final answers, you're going to have x and y, and all the other letters are going to be with numbers, represented with numbers. So you know what is A, B, and C now. So what you need to do, there are 4 equations of ellipse. We have those 2 and you have those 2. So those are 4 equations. So now the first 2 equations, if the center is 0, 0, which means if the center, if this is x-axis and y-axis, the center is going to be at 0, 0. And if the center is something else, then the coordinate of the center are given with h and k. And h and k was like the same letters for the vertex in parabola, if you remember. So now, how you know if the center is 0, 0 or something else? It's going to say, find the equation of ellipse with center. If it says 0, 0, you're going to use one of those 2. If it says center 5 and 3, you're going to use the second 2. And also, it's going to say in the question you're solving, which one is your major axis? Sometimes it's going to say major axis is located in the x-axis. Sometimes it's going to say major axis is located in the y-axis. So the example I have given here on this graph, major axis is the x-axis. So if the ellipse is open horizontally, it's major axis x. This is how major axis y looks like. So the major axis is parallel to the y-axis. So this is major and this is minor axis. And these are the vertices. So you have vertex here, vertex down here, and you have 2 focuses inside. Okay? So it's kind of flip it in 90-degree angle. So this is major axis y, this is major axis x. So that's the difference between those 2. So sometimes it's going to say major axis x, major axis y. Sometimes it's not going to say which one it is, but you can figure it out using this. So this is what you're going to use to figure it out. So major axis is x if the x coordinate is changing. Major axis is y if the y coordinate is changing. What that means? They'll give you 2 points, and looking at the 2 points, we're going to decide which one is your major axis. So before you pick one of those 4 equations, which one is going to be for your specific question you're solving, you have to read and decide what is your center and what is your major axis. And those 2 are going to determine which one of those 4 equations you're going to use. After you pick your equation, you're just going to put A and B there and you're done. So let's go ahead and start with I'm just going to do my number 8. You have different numbers, so you can do yours the same way. So what we have here, we need to find the equation in standard form of ellipse. Center is at the origin. Origin means 0, 0, right? So they already told me the center is at 0, 0. And what else? Major axis is 6, located on the x-axis. So I already know the major axis is x and center 0, 0. So looking at my formula sheet, going back to my formula sheet, which one is going to be my equation? Center 0, 0, major axis x. So this is going to be my answer. So my answer is going to look like x squared over a squared plus y squared over b squared equals 1. So I'm going to write it over here. So my answer is going to be x squared over a squared plus y squared over b squared equals 1. So this is how you have to enter your answer, exactly like that. All of this fraction plus fraction equals 1 is your answer. So what we have, they give me major axis is 6. So from the major axis, I can get the letter A because half of the major is A. So what is A? Half of 6. So 6 divided by 2 is 3. So A is 3. Half of the minor axis is going to give me the letter B. And B is going to be half of 4 is 2. So I already know A and B. So what I'm doing, I'm just going to replace A. What is A? 3 squared is 9. And I'm going to replace B. What is B squared? 2 squared is 4. So that's how my answer is going to look like. X squared over 9 plus y squared over 4 equals 1. Okay, this is 1. So that's how you enter the answer. So let me show you how to plug it in. So when you plug it in, you're going to press on the fraction. So I'm going to make it small to look at my fraction. And you're going to put x, make it square, over 9. And then you have to get out of the fraction, put plus. Then you press another fraction and you put y, make it square, over 4. Then get out of the fraction equals 1. So this is how your answer should look like that. Okay, make sure you look exactly like that. Make sure you don't use capital letters because if you use capital X or capital Y, it's going to say it's wrong. And then that's my answer. Okay, that's how we do number 8. Number 9 is the same way. So here for number 9, we're going to find the equation. We have given center is 0, 0, origin again. And which one is the major axis? It doesn't say. But looking at the 2 points given, focus and vertex. Focus is going to give me C, the letter C. So C is going to be 6. And vertex is going to give me the letter A, which is 9. Okay, we have C, we have A. Now, which one is your major axis? So looking at my points, which coordinate is changing? See, X and X doesn't change. Y is changing, 6 and 9. So major axis is Y. I'm going to put major is Y. So now I'm going to look at my formula sheet and I'm going to get the equation with center 0, 0, major axis Y. So it's going to be this one, the bottom one. Because center 0, 0, major axis Y is this one. So this is how my answer is going to look like. And I'm just going to write it here. So the equation is going to be y squared over a squared plus x squared over b squared equals 1. So the major axis always goes with the letter with the major. If the major is y, a goes with y. If the major is x, a goes with x. Okay? So now, let's see, I have a, so I'm going to replace a squared is going to be 9 times 9 is 81. Now, I don't have b, I don't have minor axis. So what you need to do for this case, I'm going to show in the formula sheet. There's a formula between a, b, and c. Okay? And the formula I'm going to use like a blue highlight so I can show you. This is the formula. Okay? Oops. So the formula you're going to use to find, I'm going to move it so I can see better. So right below equation of ellipse, if you need to find b, this is what you're using. B squared is equal a squared minus c squared. If you need to find a, you're going to use this formula. So these two formulas, I mean, they're the same formula, but I put it in different forms. These formulas help you to find a or b, depends what you need, because in the equations, you need a and b for the final answer, right? You don't need c. You don't have c on your final answer. So here I'm going to use the formula for finding b squared. So the formula was b squared, and you can look at your formula sheet also. It's a squared minus c squared. This is the formula. And I have a, I have c, so I'm going to plug it in. So what is a squared? 9 times 9 is 81. Minus, I'm going to put it down so it's easy to subtract. What is that? 6 times 6 is 36. So when I subtract 81 minus 36, what I got? 45. Okay? So now, 45. Hold on. 45. Okay? So now, if you notice here, b squared is 45. So what you're doing, you're going to replace b squared with 45. You don't square, you don't take square, just 45. So this is how my answer, final answer is going to look like. I have the final answer for the equation. So that's what you're going to enter here. And again, I'm going to put fraction. Let's make it small so I can see fraction. And you're going to put y in this case, right? Y squared. And then go down and put 81 plus another fraction, x squared over 45. And then you need to get out and put it equals 1. So this is how the answer looks like. Okay? It's going to look exactly like that, exactly the way you got it. Make sure you get out of the square, get out of the fractions, and put it exactly the way it is. Okay? Now, the next one is the same way, so I'm not going to do this again. It's the same idea. In this one, you have center 0, 0. Now, which one is the major axis? If you have 0, 0 here, center, which coordinate is changing? Obviously, x is changing. So origin 0, 0, major is x. X-axis, so it's going to be the top one. And now focus is going to give me C. C is 4. And major axis is going to give me A, so I'm going to use the same formula. Now, because the major axis is 12, half of it is 6. So A is 6, C is 4, and I'm going to use the same formula. B squared is A squared minus C squared to find B. Okay, and you're doing it the same way. Just here, make sure you use the right formula. Use this formula to find b squared, and you're going to get your equation. Okay, that was 10. Now, number 11, what you have for number 11? For number 11, you have to pick which one of the graphs here it's given by the equation. So looking at the equation, remember what I told you, that major axis is the bigger number. So here, major axis is x because 36 is bigger. So that means my ellipse is going to be like this. So it's not this one. And I'll see exactly which one it is, but I'm going to make it small in a minute. So let me explain. So looking at this, it's going to be horizontal ellipse because major is x. And then that means A is going to be 6. Because in the bottom of 36, square root of 36 is 6. And from this 4, I'm going to get B is 2. Which means from center Okay, I'm gonna show you in a minute. So actually, this is not the right one. Let's see the other one. And the bottom one is not. So you have this or this. Excuse me. Okay, so now, looks like this is the graph we have, this one here. Why is this one? Because see, the center is 0, 0, it's open horizontal. From here to here is C, 6, right? And this is A, and A is 6, exactly 6. And from here to here is half of the minor, which is 2, right? From this point to this point is exactly 2. This is 2. And that's exactly what I have, A6, B is 2. So that's my right answer, and that's what I'm going to pick and submit so I can show you. Okay? And that was number 11. Next one is number 12. It's another one like that, but here the center is not 0, 0. The center is something else. So how you know which one it is? First, looking at my, I'm gonna look it like this. So first, looking at my equation, x is in the top of the bigger number, right? So that means x is the major axis. So it's not this, and it's not this. It's a horizontal ellipse. Okay, because major axis is x, which means it's open horizontal. Okay, now, how I'm going to find which one of those it is? Let's see what is the center. If you look at the equations for ellipse with center h and k, x goes with h. So the center from these 2 points I have given, the center is going to be, hold on, I'm trying to write here. So the center is going to be opposite of the number next to x, which is 2, comma, opposite of the number next to y, which is 4. So the center is 2 and 4. How I know that? Because that's what the formula says. So going back and showing you in your formula sheet here, see the center, clear this. If the center is h and k, see those formula have x minus h and minus k. And x goes with h, y goes with k always. So that minus you have next to the between x and h tells you that you're gonna switch the number. That's the same idea for when you find the vertex of parabola. So you switch opposite of this number, and opposite of this number is gonna be the center h and k. Okay, so that's how you find that. And looking at this, hold on, I move it a little bit. Okay, so now which one is going to be my answer? One of those two. Looking at this, the center here, hold on. The center here is going to be over here somewhere, right? And this point is not 2 and 4. 2 and 4 is in first quadrant. See the center here. 2 and 4 looks more like. So this is going to be my answer. Okay? And that was the right answer. Let me show you that one more time. Oops. See, this one have center 2 and 4. The center of this one is -2 and -4. But you change it because of the formula. So you always change. So remember, you always change number next to x. If it's -2, you change it +2. And change the number next to y. If it's -4, you become +4. So make sure you always change the numbers next to x and the y and next to the y to get the center. Okay? And then pick the right one. So that was 12. Going to number 13, and then we're going to continue with hyperbola. So number 13, they give me equation and they're asking which one of the conic section is here. So how you know? Circle has equation x squared plus y squared equals number. So that's not circle, right? Because you have fraction here and equal 1. So that's not circle. Parabola is y equals, and you have x squared. It's not that, right? So here in this case, you're gonna have not parabola. It's gonna be ellipse or hyperbola, one of those two. Now, if you look closely to the formula sheets, the difference between equation of ellipse and equation of hyperbola, looking at those equations, the difference is ellipse have fraction plus fraction equals 1, hyperbola is fraction minus fraction equals 1. So the only difference is this positive or negative, depends what it is. So hyperbola has minus, ellipse has plus. That's the only difference between those two equations. So looking at my number 13, between the fractions, what I have minus, right? So because of the minus between the fractions, my answer is going to be hyperbola. Okay, everybody understand that? Okay, so that's hyperbola because you have fraction minus fraction equals 1. Now, going back to number 14, and the rest of it is, the rest of the questions we have is a hyperbola. So we have hyperbolas, everything left is hyperbola. So how you do hyperbola? The same way you do ellipse. So we have number 14 is the next one. So let me explain hyperbola. So looking at the formula sheet, the only difference between ellipse and hyperbola is that negative between the fractions. And this is how the graph looks like. So what you have here, we still have center 0, 0, or something else. So you still have to pick which one it is. Center 0, 0 or center something else is going to say in the problem. Now, hyperbola looks like this. The major axis is this one. So let me write on top of it here. So this is the major axis in this case, and major axis is x. So when everything is on all the points on that axis, that's the major axis. So you have the vertex, you have center, you have focus. Again, there are two of those focuses, two of those vertices. So the major axis is x if it looks like that. Let me show you how the major axis y looks like. So it's going to be like this. You have minor axis here, and the hyperbola is going to be like this, up and down. So these are the vertices. You have two vertices here. You have center in the middle, that's the center. And you have two focuses. So this is center, this is vertex, and this is vertex also. And the focus is the inside. So the focus 1 and 2, there 2 again, is going to be inside. So this is the focus, and this inside here is going to be another focus. So you have two vertices and two focuses symmetrical through the center. Okay? So that's how you figure it out which one is the major axis. The same way, the axis, the coordinate we change, that's the major axis. If the x coordinate change, major axis x. If the y coordinate change, major axis is y. Okay? And the same way you have here. You have A, B, and C, the same way. Center to focus is C, so the focus give is C. Half of the minor is B, the same way. Center to vertex is A, and also half of the major. Everything is the same, just the difference is that negative. Also, I want to show something else here. Also, there are formulas how to go from if you need A or if you need B. These are the formulas to change to find A and B if you have given C. Okay? So pretty much the same idea, the same formula, the same everything. This is A, B, C, the same letters. Just that little negative sign changed the shape from ellipse to hyperbola. So be careful with the negative. Be always positive. No, just kidding. Okay, next one. Let's go ahead and start with number 4. So here we have the center is 0, 0. We have given focus and vertex. So which coordinate is changing? Obviously, x coordinate is changing because the first numbers are different. The second numbers are 0, 0, 0. All of these 3 points actually. The x coordinate is changing. So that means major axis x. And then x is major. So if the x is major axis, we're going to pick the equation for major axis x and center 0, 0. And if you look at your formula sheet, I'm not going to show it here. Just look at your formula sheet. This is the equation. Or let me show you. It's it's x, let me write it. X squared over a squared, always the major goes with a, minus y squared over b squared, b is the minor, equals 1. So this is the equation, and let me show you that it's right on your formula sheet. So you have center 0, 0, major axis is x. So this is the equation you're going to use in this case, right? X squared over a squared minus y squared over b squared equals 1. Okay, so that's the equation we're going to use. And what you need to do is just find a and b. Now, what is given? Focus. Focus give me c. What is c? 5. Because from 0 to 5 is 5. Vertex is going to give me a. What is a? Then 0 to 2, the distance is 2. So right now I can replace a squared is going to be 2 squared is 4. Now I don't have b. I'm going to use the formula for b squared is c squared minus a squared. This is the formula for hyperbola. Make sure you look at what it is, ellipse or hyperbola. So b squared is c squared minus a squared, and I'm going to plug it in. So c squared is 25, 5 times 5 is 25, minus 2 times 2 is 4, so that gives me 21. So b squared already is 21, so I'm just going to replace b squared with 21. Now here for hyperbola, a is not always bigger than b, so it doesn't matter if the numbers are bigger or smaller. The negative tells you which one is the major axis. So if it's positive fraction, that's the major. The fraction with the negative is the minor. Okay, that's how you know. And then we're going to plug that answer. So when you plug it in, I'm going to make it smaller so I can see the math part in the side. So we're going to put fraction again. And I have x, make it square, over 4, get out of the fraction, minus, be careful the sign is minus, y, make it square, over 21, get out of the fraction, equals 1. And this is how you're gonna plug it in. This is how the answer is gonna look like. And then let's submit it. X squared over 4, okay, that was right. So that's how I do number 14. I'm gonna show you 16 is the same way. You have focus, you have vertex, just the same idea, the same way. I'm going to do 15. Just the numbers are different for 16. 15, it's a little different because you have not center 0, 0, you have center something else. So that means I'm going to use the equation in this side, one of those. Okay, which one? Let's see, which coordinate is changing here? So we have x is -1, x is 1, x is 3. Obviously, x is changing, right? Because y, see the second number is 3, 3, 3. So y doesn't change, x change. So that tells me I'm going to use this equation. Major axis x, center h and k. So from the center, I'm going to put this number here and this number here. Okay, so from the center, I'm going to fill out the top. So let's go ahead and start with this. And I'm going to screenshot this again so I can put it in a Word file. It's easier that way. And then I'm going to put the answer here. Okay, I'm gonna just plug this. Okay, so I'm gonna write here. So we have center, we know center is h and k. So the first number is h, the second number is k. Now, because we know that vertex give me a and focus give me c, now I'm not just gonna get these numbers because I'm not counting from the 0, I'm counting from -1. And center to vertex is A. So how I'm going to do that? I'm going to make a number line and I'm going to put all the points there and I'm going to count the distance. That's the best way to do it. So center is at -1. And then the number line goes 0, 1, 2, 3, 4, and so on, right? So now center is at -1. vertex is at 1. So this is the vertex, and the focus is at 3. So now the second number 3 doesn't matter because this is the y coordinate. You're just going to count in on the x-axis. So starting with A. A is from center to vertex is A, right? So how many steps I'm doing? 1, 2. So A is going to be 2. And then you do the same way to find C. Center to focus is C. So you're going to count from -1 to 3. So you have 1, 2, 3, 4 steps. So C is going to be 4 and A is 2. I'm going to write it here. So after you count from the center, you get A is 2 and C is 4. So now we have equation of hyperbola. I'm just going to copy this. That's why I like using Word, because it's just easy to copy and paste. So this is my equation, right? We have center HK, major axis X, and I'm going to put that equation over here. Okay, so this is my answer. It's going to look like that. Okay, so what that means, I'm going to just replace. What is H? H is -1. Just going to put it here. Or you know what? I don't need to. I'm just going to plug it in. I'm not going to just. Okay, so I'm just going to plug it in here. So we have center, it's -1. So in the place of H, I'm going to put -1. Now, if you have negative, negative, 2 negative is going to make it +1. So change it, right? K, what is K? K is 3. So it's going to be y minus 3. So that's what you have in the top. Now, let's see what is in the bottom. A is 2. So in the bottom of the fraction, I'm going to put 2 squared, which is 4. Just put the number 4. And then I need to find B. I don't have B here. So I'm going to use the formula B squared, C squared minus A squared. That's the formula for hyperbola. See, let me show you. So for hyperbola, you're going to use this formula. B squared, C squared minus A squared. That's what you're using. And I'm going to plug it in. C, 4 squared is 16, minus 2 squared is 4. So 16 minus 4 is 12. So B squared already is going to be 12. So I'm just going to go here and replace B squared with 12. And that's how my answer is going to look like. Okay, and I'm going to plug it in exactly like that. So I'm going to go here and I'm going to put, this is how you enter it. Fraction. And then you do parentheses, x plus 1, close the parentheses, and then you press square. Over, what was that, over 4. And then you get out and you put minus another fraction, parentheses, y minus 3, close it, and then squared, over 12 equals 1. Let me double check, is it 12? Yes. Okay, so make sure you have everything exactly the way it is. Plug it in the Weber sign, and it have to look exactly like the way it is in the formula sheet, okay? So that's how you do number 15. 16 is the same like 14, so I'm not going to go over that again. Number 17, it's another one where we have center H and K, but here they just give me what is A and what is B. So we're just going to use the formula. So the formula is x minus H squared over A squared minus y minus K squared over B squared equals 1. So we're just going to plug it in the numbers. Here we have everything given. So center is 1 and 5. So I'm going to replace this is 1. And you're going to replace K is -5. So if you have negative, negative is going to be +5. And then A squared is already 9. They give you A squared, and B squared is 4. So everything is given. You just have to plug it in exactly like that. I'm going to make it smaller so I can see fraction. And again, you put parentheses, x minus 1, close it, do the square over 9. Out of the fraction minus another fraction, parentheses, y is going to be plus 5 because you have negative and negative make plus 5. Close it, square, and then over 4. Make sure you put it equals 1. If you forget to put equals 1, all the equation have equals 1. If you forget to put that, it's going to say it's wrong. And let's check it out. Okay, that was the right answer. So that was easy. And then the last question for lab 5, week 6 is another hyperbola, which is the same way. I just want to explain there's a little trick here. Center 0, 0, which one is the major? Obviously, x is changing, right? So if the center is 0, 0, major axis is x. The equation is going to be x squared over a squared minus y squared over b squared equals 1. That's the equation. And then you're going to plug it in. From the vertex, you're going to find a is 9. So that gives me a squared is 9 times 9 is 81. Now, focus is going to give me c. Now, the focus is negative 15. But if you remember, there are two focuses, right? You have center at 0, 0. You have focus at negative 15. So what is the distance from negative 15 to 0? The distance is 15. Because there's another focus at 15 also. So the distance from two focuses to the 0, they're symmetrical, so it's going to be 15. So here you're not putting negative 15, you're putting 15 because A, B, and C, they're always positive numbers because they're distances. So keep that in mind. And then you're going to use the formula B squared is C squared minus, which is 15 squared minus 9 squared. And then you can use calculator. And you can get the answer. Minus 81 is 144. And that's what you should put here. The answer should be fraction. And then you have x squared over 81. I'm going to plug it in so I can double check. Minus fraction y. Oh, I did another fraction. Hold on. Y squared over 144 equals 1. Make sure always put it equal 1. Okay, that was good. So that concludes the lecture and the video for lab 5, week 6.